Hello, geometry! So today we are looking at some special right triangles. So basically, just some specific cases of what was going on with the Pythagorean theorem before. Now, any of these you can honestly just solve with the Pythagorean theorem. These are just some shortcuts to make it a little bit quicker with some specific triangles. And again, watch out for these only work for right triangles and only for these specific kinds that we're going to be talking about. So don't use these on any other types of triangles. So the first one we're looking at is a 45, 45, 90 triangle. And again, only right triangles. So what's going on with a 45, 90 triangle is if I call this side down here x, remember, if both of these angles are the same, that makes this an isosceles triangle. So even if it's not marked in there, these sides are the same because the angles across from them are the same. So if this is x, that one's also going to be x. Okay, well now we have two sides of our triangle, even if we don't have a specific number to go with that. We're going to throw in some numbers in a moment. I just wanted to do an example without numbers so we can figure out what's going on with the pattern. So if we take this and plug it into the Pythagorean theorem, I've got x squared plus x squared equals, I'm going to call it c for, c squared, just because that's what we usually call the side of the hypotenuse of our right triangle. So x squared plus x squared, 1x squared plus 1x squared, because even if they're not written in there, we have a 1 hanging out in front of both of those. So I'm going to call that a 2x squared equals that c squared. So then if we want c, we're getting rid of squaring something by square rooting it. So I'm going to square root that. I'm going to square root that. That cancels out that squared over here. And it cancels out this squared. So the only thing left under that square root is that 2. So this hypotenuse here is whatever this side is times the square root of 2. Any 45, 45 triangle, that's going to work. Well, 45, 45, 90 triangle, that's going to work. So this side is whatever either of these two sides are, because these are going to be the same, times the square root of 2. Boom. Now, that makes it really nice if we're trying to find either one of these sides or one of these sides, because if we have these sides, we can just take it times the square root of 2. If we want to go backwards, we can just divide by the square root of 2. So that might be something you want to jot down, is that if we have a 45, 45, 90 triangle, your hypotenuse is going to be your leg times the square root of 2. Okay. Now, what we can do with that is if we have either the leg or the hypotenuse, we can go through and find the other one. So this one, I've got my leg here. So my leg is 17, which means this other leg is 17. And even if it's not written in there that these are 45-degree angles, the fact that these two sides are the same means this is a 45, 45, 90 triangle. Because in order for these two sides to be the same, those two angles had to be the same. And if it's a right triangle, that's only going to happen if your other two angles are 45. So we could go through and Pythagorean theorem this, or our little shortcut says we can just take 17 times the square root of 2. Now, you may see the answer in the book just written like that. So if you see it left like that when you're double checking your answers in the back, don't freak out. It's okay if you leave it like that. I'm also okay with you turning that into a decimal. So if we take 17 times the square root of 2, 17 times the square root of 2, gives you about 24.04-ish. So either one of those is okay. If you're double checking your answers in the back of the book, they'll probably have this. They might have this to go along with it. Just if you see this, don't freak out. Same thing. Okay, now we're going to go backwards. So if we're going backwards, instead of multiplying by the square root of 2, we're going to divide by the square root of 2. So we're going to take that 8 divided by the square root of 2, which gives you about 5.65-ish. Actually, 5.6 That would round to 6. Now, what you won't see in the book is you won't see this. You'll see them rationalizing the denominator by doing this and taking it times the square root of 2 and taking it times the square root of 2, and that cancels out these square root of 2's. So now I got 8 square root of 2 over square root of 2 times the square root of 2 is just 2. So if you see this, that's where they're getting that. I'm okay if you do this. Just if you see that, don't freak out, that's the same thing. And if you want to double check and see if it's the same thing, you can go ahead and punch 4 times the square root of 2 into your calculator, and it should give you this. So I don't care if you have this or if you have this. We didn't really deal a whole lot so far with the rationalizing the denominator thing. We'll get to some more of that in Algebra 2. So that'll be back. Just if you were wondering where they're getting that number from, that's where they're getting that number from. If you want to do that, that's fine. Not the main idea right now. Okay. The other type of triangle we're dealing with is if we have a 30, 60, 90 triangle. And actually, in order to figure out what's going on here, I'm going to draw another one of them, and I'm going to draw it over here. Because if we draw another 30, 60, 90 triangle over here, we've actually got an equilateral triangle. Because if this is 60, and this is another 30, 30 and 30 is 60, 60, 60, 60 makes this an equilateral triangle. The reason that's nice is if I call this side of my 30, 60, 90 triangle X, and this is also X, that means that all of these sides, so this one, and this whole thing down here, are going to be 2X. Cool. Now, if we want to find what the other one is, we're going to take this triangle, so we're going to take this triangle, I'm going to call this B. We're going to take our x and our b and our 2x, and we're going to Pythagorean theorem that. So I'm going to call this x squared plus b squared equals 2x squared. And again, you're not going to have to do this with all of them. I'm just going through this so you can see where the little shortcut we're going to find is coming from. And we're going to take that 2x and we're going to square it. So 2 squared is 4, x squared is x squared. We're going to subtract an x squared. And watch out for that doesn't cancel out your x squareds. This is really just a 1x squared. So 4x squared minus 1x squared is 3x squared. And we're going to square root those. And same sort of thing as with the 45, 45, 90 triangle, that square root's going to cancel out the squared over here. And the only thing left inside your square root is a 3. So this side is going to be x times the square root of 3. So that part up here is what you probably want to jot down. If you have a 30, 60, 90 triangle and you have this side is the shortest side times 2, and this side is your shortest side times 3. I'm going to write that out a little bit more with words down here. If you want the picture, that's fine. If you're a words person, your hypotenuse equals your shorter side, your shorter leg, times 2. Your longer leg is your shorter leg, times the square root of 3. So if you like pictures, jot that down. If you like words, jot that down. I would jot down one or the other. And really the big thing with this is not getting it mixed around with the 45, 45, 90 triangles that we were just dealing with. Because both of them have square roots in them, so if it's a 45, 45, 90 triangle, everything is square root of 2. 30, 60, 90, everything is square root of 3. Okay, but we're doing the same thing with them. So we're going to have one side and we're going to be finding the others. So if what I have is the short side, okay, I've got my shorter leg here, and we just said that our hypotenuse is our shortest side times 2. So that one's easy. We can just take 5 times 2, that gives you 10. And again, this only use it with 30, 60, 90 triangles, but since we've got this 60 here and this right angle here, even if it's not written in there, the other one has to be 30, because triangles have to add up to 180. Okay, and then this side is just going to be 5 times the square root of 3, and again, it's okay if you leave it like that, or if you punch in 5 times the square root of 3, that gives you about 8.66. So, again, I'm okay with either of those. Just a heads up that the back of the book will probably have this. This is also fine. Okay, what if we're starting with our hypotenuse rather than one of our legs? So, same sort of thing, but in reverse. So if our hypotenuse is our shorter side times 2, our shorter side is going to be our hypotenuse divided by 2. So we're going to take that 20 divided by 2. That gives you 10. And then our longer leg is our shorter leg times the square root of 3. And again, it's okay if you leave it like that, or if you take 10 times the square root of 3, you get about 17.32-ish. So again, back of the book will probably have this. This is also okay. And really the big thing here is just not mixing around which thing goes with which thing. And in general, I know I keep saying things aren't drawn to scale, but if you get a number for this side that's longer than what you had for your hypotenuse, something went wrong. So your hypotenuse should end up being your longest side. The one across from 30 degrees should be your shortest, and your middle one should be somewhere in between those two. So if that's not happening, you probably just mixed up whether you're multiplying or dividing by something somewhere along the line. So your side should come out with numbers that make sense. Okay, now, what if our triangle is inside a square? Okay, so if we've got a square here, we've really just got a 45, 45, 90 triangle. We've just got 2 of them. So if we didn't have this other half of this square, and we just had this hypotenuse of our 45, 45, 90 triangle, 45, 45, 90 triangles all have the square root of 2. So we're going to take 6 divided by the square root of 2. And again, in general, you'll probably be able to tell if you multiplied instead of divided, because this side of your square should not be longer than your diagonal going through your square. So in general, whether you're multiplying or dividing, you should be able to figure out which one you're doing by, are we looking for something shorter or something bigger than the thing we started off with. So if we're looking for something shorter, we're probably dividing. So 6 divided by the square root of 2 gives you about 4.24-ish. Okay, same sort of thing over here with our 30, 60, 90 triangle, which we know is a 30, 60, 90 triangle because, actually, technically we don't know that until I do this. You're right, I should have drawn a little right angle in there. Okay, I'm assuming you definitely pointed that out. This P, we don't know that's a 40, 30, 60, 90 triangle. Okay, so if this is a right angle, so we have an altitude going down from the vertex of our equilateral triangle. If we have an altitude here making a right angle, that's going to give you a 30, 60, 90 triangle, because in order to be an equilateral triangle in the first place, these are 60, and altitudes are giving you the 90, which means we have the 30 automatically, even if it's not written in there. Now, this time we have our longer leg, and we want our hypotenuse, but we're probably actually going to want to find this first, because we know our longer leg is our shorter leg times the square root of 3. So that means our shorter leg, if we're going backwards, is our longer leg divided by the square root of 3. So 8 divided by the square root of 3 gives you about 4.61-ish. Yeah, 4.62-ish. Okay, so that's your shorter side, and just watch out for that's not the thing we were looking for. The thing we were actually looking for was your hypotenuse here, which is just going to be 2 times your shorter leg. So 2 times your 4.62 gives you about 9.24. And again, if you left that in terms of square roots, that's fine. If you turn those into decimals, that's fine. Just a heads up that the back of the book might have it in terms of square roots. If you want to double check and see if that's the same thing, just take that square root thing, plug it into your calculator, and see if it gives you the decimal. Now, if you have one of those calculators where if you plug in like 3 times the square root of 2, if you have one that gives you 3 times the square root of 2 back as your answer, remember, just take that times a 1.0, and that'll tell your calculator, no, give me a decimal instead. Okay, and that's pretty much it for special right triangles. Again, remember, just use it for those triangles. Don't start using these as every single triangle. So, go ahead and check out the homework in the description below, and I'll see you in the next video.